Welcome to the presentation on bias in AI and machine learning. In this chapter, we will explore the concept of bias in artificial intelligence and machine learning systems and its potential implications. Let's dive in. Introduction to bias in AI and machine learning. Bias in AI and machine learning refers to the unfair favoritism or discrimination present in AI systems. It can arise from biased data used for training and biased algorithmic design choices. Understanding and addressing bias is crucial to ensure fairness and ethical considerations in AI applications. Types of bias. There are two main types of bias: data bias and algorithmic bias. Data bias. Data bias occurs when the training data is unrepresentative or skewed. This can lead to biased predictions or decisions. Underrepresentation of certain groups in the data can cause disparities in AI outcomes. Algorithmic bias. Algorithmic bias arises from the design and implementation of machine learning algorithms. Algorithms unintentionally learn and amplify existing societal biases present in the training data. This results in discriminatory or unfair outcomes. Consequences of bias in AI. The consequences of bias in AI can have significant impacts on individuals and society. Reinforcement of social inequalities. Bias in AI systems can reinforce and perpetuate existing social inequalities and biases, leading to further marginalization of certain groups. Discrimination in decision-making. Automated decision-making processes, such as hiring, loan approvals, and criminal justice, can be influenced by biased AI systems, leading to unfair treatment and disparate outcomes. Mitigating bias in AI and machine learning. It is essential to mitigate bias in AI and machine learning systems to promote fairness and equitable outcomes. Diverse and representative data. Ensuring diverse and representative training data that accurately reflects the population can help reduce bias in AI systems. Data audits. Regular data audits should be conducted to identify and rectify potential bias in the training data. Fairness-aware algorithms. Developing fairness-aware algorithms that account for potential biases can help mitigate discrimination and promote equitable results. Transparency and interpretability. Striving for transparency and interpretability of AI systems allows us to understand and challenge bias, ensuring accountability and trustworthiness. Ethical guidelines and regulations. Establishing ethical guidelines and regulations can provide guidance for the development and deployment of AI systems, ensuring responsible and unbiased practices. Thank you for joining this presentation on bias in AI and machine learning. If you found this content informative, please consider liking, sharing, and subscribing to our channel for more insightful discussions on AI and related topics.